So good morning, good afternoon, and good evening, guys, based on the time zones you all are coming from. So guys, before we start with the session, can you all please give me a quick confirmation if you all can see my screen and hear me loud and clear as well? Perfect. Thank you for the confirmation, everyone. So now let's get started. Now, the main agenda for today's session is we'll be discussing on deep learning. What exactly are neural networks? What are the different libraries available in Python? What exactly is PyTorch? What are different use cases of PyTorch? And then we'll be having a quick summary on whatever we have discussed so far, right? So that's in a nutshell of what we'll be covering today, guys. So now let's get started. So first of all, let's understand the deep learning. So how deep learning has exactly changed our world, right? For example, when we are talking about when we are talking with any virtual assistant that we can think of, like we have Alexa, we have Siri, we have Google Assistant, right? So again, these all have been advanced by machine learning. So first, earlier we used to have machine learning, right? But where we trained the entire system with among multiple learning methods, like we have supervised, unsupervised, and then we have reinforcement learning methods, right? And then we have moved from machine learning now to deep learning, where we are training the entire system to be self-sufficient as much as possible. And in terms of deep learning, and it is applied in virtual assistant, when again we are building system to recognize faces, right? So now you must be seeing there are multiple camera applications who can recognize faces, right? Who can transform the faces based on age, on gender, who can classify the faces on the basis of age, gender as well, right? Age, gender, ethnicity of the entire faces here, right? They can define those, correct? And then we have all the recommendation systems, like for example, if we talk about social media platforms, if we have streaming applications, like we have Netflix, we have YouTube, right? So they all are learning from the user's behavior. They all are learning what exactly has been the pattern of users, right? How they are using the applications, and how we can improve, and how we can learn from the behavior and to improvise and give a better recommendation to them, right? So for a simple example is when we are watching videos over Netflix or YouTube, right? So earlier YouTube only analyzed, suppose how many videos we have watched, what are different type of videos that we have been watching. Suppose if we have watched 10 comedy videos, right? Then we'll be getting more recommendations for comedy videos, right? But now things have changed. Now even now each and every small pointers are being taken into account as a part of deep learning. That means how much of video we are watching, right? Suppose even if we have started any video, then suppose if we are skipping to one single part of the entire video, right? Then what kind of content to that particular part contains, right? How much time we are actually watching the videos, right? Suppose we may have played 10 comedy videos, but again we haven't watched them, right? We have only watched them for a couple of seconds, right? And we have watched two videos for action, but again that has been full length, correct? That means we are more interested in action than on comedy, right? And again, even in terms of comedy, what kind of comedy do we like based on how many times we are pausing the videos, at which section we are pausing the videos, right? And again, for which particular actor we are watching the videos, at what time of day we are watching it, right? Suppose in the morning we have a different preference, right? And that too on the day as well. For example, on Sunday morning we like to watch some inspirational videos, right? And that too from a particular person or a channel, right? Whereas on Thursday evening we want to watch some other videos, right? So based on our preferences, what kind of videos we are watching, what has been our pattern, how much time we are giving to it, how many times we are pausing it, how at which particular section. So these all are advanced sections that we need to analyze here, right? And this happens for any applications because now the competition is stiff. And now we need to take again to our next level, right? Same way for email spam filtering, right? So again, in emails as well, we have multiple algorithms that we design here. That means how many times, what is the word used in the emails, right? Suppose the word free, buy, offers, these are used many times. That means they are again a part of promotional emails, right? If the words like we have prices or win money or order something has been used multiple times, again that's a recipe for spam, right? If there are too many images available in a given email, if there are too many links available, right? And when we talk about links, what is the content available in those links? Suppose we have added 5 links to our email, right? So it will not only analyze how many links are present in an email, but what the links which have been added, what is the content available on that particular link altogether, right? And how exactly it relates to the email that we have shared, right? And plus at what time we are sending the emails, what is in the subject line, from which particular server we have shared the email. So there are multiple pointers again which helps these mailing systems in segregating the emails that are important, genuine from these spam emails, right? And that's why Gmail has been so smooth, because again the algorithm used there for the entire deep learning used there is much smoother and more accurate as compared to other platforms, right? Because it knows what kind of email and what kind of algorithm has to be applied for sorting these things out, right? So these are some of the small use cases through which the entire system is being changed by using deep learning, right? And that's how important deep learning is, especially nowadays, if we talk about different solutions that we are using on a daily basis here, right? So next is we have deep learning. So first of all, let's start by having a good understanding of what exactly deep learning is, right? So first of all, we have artificial intelligence as a domain for data, right? So artificial intelligence is simply making the entire machines and programs intelligent. Now, when we talk about intelligent, suppose we have given the system a small command to calculate x plus y, right? But before calculating x plus y here, now system recognize that it needs to cleanse x first, right? It needs to convert x to some other values before it can add up x plus y, correct? So again, these things have to be analyzed first, right? For example, we have mentioned x as 9 and y has been mentioned as 8, but that too in the alphabets, right? So now first of all, in order to perform the operations, the arithmetic operations, first of all the system instead of giving a simple error, it should be able to convert that character value into integer automatically, right? And then it should start making additions, right? So these things are again have to be done by the system automatically, right? And these are small use cases for artificial intelligence, right? Next is we have machine learning. So machine learning is simply giving the system ability to learn without being explicitly programmed, right? Just like we had discussed the example just now, right? Suppose now we have now, and it's more or less the same way that we train any particular kid, right? Suppose how do we train kids? We train them, if we train them, okay, what is 2 plus 2? 4. All right. What is 5 plus 5? It is 10. What is 7 plus 5? It is 12. Good. Now, when they set into the exam, now they get questions. Okay, solve 12 plus 121, right? Now, we haven't trained them on 3 digits addition, but whatever they have learned on how the numbers are added up, they can apply the same logic to solve a bit more complex problem, right? And this is what we train them as a part of machine learning, right? And then we have deep learning. So for example, if we have trained them how to translate English into Mandarin, and we have also trained them how to translate Mandarin into English as well. We have trained them how to translate English into French, and we have also trained them how to translate French to English, right? So now the system can start learning on itself. That means now it would be in a position to translate French directly into Mandarin, because now it has evolved, right? So based on multiple permutations and combinations, and based on how well it has been trained, it can start giving us the answers for more complicated problems automatically, right? As a part of deep learning, here. Next part is, let's discuss on the concept of neural networks, right? Now, neural maps to neurons. Now, it is same like just like we have neurons into our brain. Now, we must have studied neurons back into class 9, I guess. So in class 9, the biology, if we have back into our school days, we must have studied how exactly our human brains works, right? So human brain, as we know, is made of multiple neurons. So there are billions of neurons that together make up our brain, right? So neurons, now this we may remember learning neurons from this diagram, right? So in neurons, we have the entire cell body that works like a nucleus. We can see the heart of the entire neuron here, where we have multiple mitochondria, right? Then we have multiple dendrites, which acts like a connector between different neurons, right? And then the central part is called as axon, right? So the main use of dendrites, again, as we have seen, that it is basically used for receiving signals from other neurons, right? So they are connected to some other neurons where they can exchange signals between them, right? And cell body, it sums all the input. That means it is the heart of the entire neuron where the entire calculations are being done. And axon is basically used to transmit signals to the other cells, right? So that the execution, now once the processing has been done by a cell body, its execution can be, now what needs to be done, that part can be executed by axon itself as a part of human brain. Now this is how the entire cell for every human the entire cell works for human brains, right? And the same concept for neurons is also applied in AI as well. In AI, right? So in AI, what we do is we do have the concept of an input layer, then we have a hidden layer, then we have a second hidden layer, and then we have the output layer, right? So the main processing is done in these hidden layers, and then we combine them to get an output for the same as a part of neural networks, right? Now, in terms of understanding this in deeper, we do have multiple types of neural networks, right? So, for example, a computer model device to represent the ability of the brain to recognize and discriminate, so that we can find differences between two different given scenarios or objects or any other thing. And again, the simplest and oldest model of neuron as we know it, again, if we have two multiple inputs coming in, and we have the activation function, and then we can define the output of it, right? And that's why we have the concept of feed-forward neural networks, right? And basically, when we are going for supervised learning, we basically use feed-forward network. Now, when we are talking about supervised learning, that means we are training the system based on the data, right? Just like for example, if we are training any system, what is 2 plus 2? 4. What is 7 plus 5? 12. What is 9 plus 2? It is 11, right? And then if it sees a problem stating what is 19 plus 37, it can simply predict the output because we have already trained it on basis of data, as a part of supervised learning, right? And in supervised learning, all nodes are fully connected. There is no partial connection between multiple nodes, right? And this is basically used when data is neither sequential or nor it is time dependent, right? Because again, when we talk about time dependent, we simply mean data is not getting changed. Data is not getting changed even as per the time is allocated as well, right? And in here, there are no back loops available. So once we have the output here, there are no back loops available as a part of feed forward, because that's the name as it suggests, right? Next, we have back propagation, right? So again, if we are using any particular algorithm here now, although they all are vehicles having multiple tires here, right? But again, the last one here is not classified as a car. It is not classified as a car here, right? And that's why, as you can see now, although based on whatever we have been training them, now the last one here is a car itself. Last one here, it's a car itself, right? And again, and that's why we have back propagation. So back propagation is simply a training algorithm where we can define it for making sure the errors happening in especially in the image classification area, right? That's reduced to as minimum numbers as possible, right? Basically, we can say forward propagation is a part of the back propagation algorithm itself, right? Where we can use it for propagation from the errors that is happening into the entire system altogether, right? So basically, the entire in terms of understanding the entire architecture here, first of all, we can feed forward the values here. First of all, we can feed forward the values here, right? And then we can calculate the error and the amount of it. That means how much error we are getting here, right? And then we can propagate back, and then we can simply work this on as a part of loop altogether until and unless the entire system has been perfected, here. Now, in terms of programming languages that can be, or we generally use here, so there are multiple languages allow support for working with neural networks. There are multiple languages that can be used for designing the neural networks here, right? Like we have Lisp, we have Prolog, we have Java, where Java and Python is most widely used here. So basically, many of the developers they use Python, especially for beginners, because Python, as we know, as compared to other languages, Python has the least amount of grammar. So basically, and again, it has multiple inbuilt libraries that is used specifically for data manipulation, and we have multiple libraries available for data science as well, right? For data science, for AI/ML that we can use directly to get started. And because of these libraries, the code here also becomes lightweight. For example, if for developing a functionality for the same functionality here in Java, we may have to write 10 lines of code in Java, where the same functionality in Python can be achieved in just 2 lines, 2 or 3 lines, right? That's the entire difference in Python there is as compared to other languages out there, right? And that's why Python is most widely used both in data science and also in the AI/ML field altogether, right? Although other technologies have their own use cases and advantages over Python, but again, the use case here is limited. Use case and in terms of popularity, it is limited as compared to Python altogether, right? And here we'll be focusing on Python used for deep learning, right? And there are multiple libraries that we use for deep learning here. We have multiple libraries that is inbuilt in Python that we use for deep learning, right? So in terms of the libraries here, we have multiple libraries available. Let me show you that. So here we have Theano, we have PyTorch, we have Keras, we have TensorFlow, right? So these all are libraries available in Python that we can use for a wide spectrum of use cases, right? For a wide spectrum of use cases here. So Keras is, we can say, a lightweight where we can use it for simple use cases. Where now the using Keras is also much easier. But again, if we have complex data, if we have large sets of data here, then we generally prefer TensorFlow for that, right? So that's why we have PyTorch, we have Keras and TensorFlow. So PyTorch is relatively new library that has been introduced, right? So PyTorch is a Python specific computing package, right? So you can say it's a Python specific computing package, and basically it is targeted at 2 sets of audience, right? So first of all, we can use this as a replacement, right? So we can either use it as a replacement for NumPy, right? To power now that can simply help us in using the power of the GPUs, right? And again, it can also offer deep learning research platform that can be used to provide more flexibility and speed, right? So that's why it is targeted at 2 sets of audience here, right? And again, it offers a complete Python support. It is actively used in Facebook as well. It has multiple APIs. It has multiple APIs that we can use it for integrating with other applications, right? And we also get multiple dynamic computation graphs that we can generate out of PyTorch. We can generate out of PyTorch here. We can do that, right? And again, it's fast and it feels native. And again, they are multiple support for NVIDIA as well, right? So basically, now when we talk about native support for Python, again, it has the functionality for all the libraries here, right? And this is also used actively in development of Facebook, right? So again, Facebook is also using PyTorch for all its deep learning systems out there, right? And again, there are multiple APIs available where we can use it, but we can say much easily for when we are integrating this with other solutions, right? And then we have dynamic graph creation that we had discussed already. Then we have PyTorch. So again, PyTorch again is fast and reliable, and again it supports COD and NVIDIA, right? So basically in here it simply decreases the time required to run the code, and it simply increases the overall performance of the entire system, supporting the NVIDIA platform here, right? And PyTorch is simply a cousin of the Lua-based Torch frameworks, and again it is not a simple set of wrappers to support popular language, right? And that's why it is again, it is one of the main driving factors even for Facebook for its entire deep learning systems out there, right? Now, in terms of the major PyTorch components, now let's discuss on these here. Now, we do have multiple concepts here that we have to discuss step by step. So first of all, we have tensors. So tensors are, now in simple layman terms, we can say tensors are similar to NumPy's dimensional arrays, right? It is similar to NumPy's dimensional arrays, which can be now again, and when we add this to multiple, now again when we with the addition that here tensors can also be used as a GPU to accelerate computing, right? So again we can simply say it is similar to NumPy's, right? But again it has the advantage of adding the, or we can speeding things up, especially for GPU here, especially for GPU scenario here, right? Now next is we have variables. So variables are simply, they act like a node in the computational graph itself, right? So basically it is used for storing all the data and the ingredient available, right? And then we have the concept of modules, right? So modules again, they are used for storing state and for learnable weights altogether, right? So that's what we had discussed here. So now in here, let's do one thing. Let's do one thing now. First of all, in order to understand tensors here, let's simply now we can use any particular ID here. We can use any particular ID here, and then in that ID we can simply construct a simple tensor, and then we can check the output altogether, right? So now let's do one thing. Let's simply create any 5 by any matrix here, and then we can check the output. So now let's open up any particular IDE. So we can use any IDE to get started, guys. Now in here we'll be using one of the most popular IDE that we use is PyCharm. So PyCharm is basically a platform offered by that means not offered by, but again it is specifically used for developing on top of Python altogether. So although we can use multiple other IDs as well, guys, there are multiple IDs that we can use here. There are multiple IDs, right? Like we have Jupyter, we can use Visual Studio, we can use Sublime. There are multiple IDs that we can use to get started on working on top of deep learning networks. So we can do that. And the main advantage for Jupyter is, again, if you want to try working on Jupyter, we also get the complete platform offered directly into the browser altogether. So let me now, and again, in any case, if we want to start on PyCharm as well, depending upon the system here, we can choose accordingly. So if we click on download, we would be able we would be taken to the download page. So PyCharm is available for all three platforms, for Windows, for Mac, and for Linux as well. Now, once we have downloaded, and now just like normal software here, we can download and set up this entire ID here. And again, if you want to get started, we also get a complete community edition as well. So we have enterprise as in professional, where we can use it for getting started on integrating Python with other system as well, right? So again, if we are developing a full project on any of these, then we can use a professional, or if you're looking to develop on core Python, then we can use the community edition, which is free of cost, right? So once we have downloaded this, we can simply open it up, and here we can now, before getting started, we can simply make sure that we do have the libraries installed into the interpreter that we are working on, right? So before starting a new project, we can simply go to the preferences here, right? So here we can simply go to the preferences where we can change the configuration settings for the interpreter. So let me show you that. So once we go into preferences here, it will be simply showing the list of all the libraries that we have already available for getting started, right? So again, if you want to install a new library here, we can simply click on add, and then from the entire package, we can choose the library that we are looking at. For example, if we are looking at the library for Torch, so here we can see the entire library list here. So again, suppose let's say we were trying to install Torch here, right? Where we can use it for tensor and dynamic neural networks. We can simply click on install package. We can choose the version, and then we can get started on top of it. We can do that. So as you can see, this has been installed successfully. And same way, if you want to install, suppose if we have multiple other related libraries available for Torch, right? For Torch layers, for Torch flame, and these are multiple libraries available, right? So we don't have to worry about installing these manually. We simply can choose the library here and then click on install package. So that's one of the advantage we get with PyCharm, where we can get the support for multiple libraries and we can install them without worrying about the manual method, here. Now, once we have all the libraries installed here, we can simply close this. We can simply close the interpreter. Click on OK. And now we can start creating a new project. Suppose we can name this as PyTorch. We can name this as PyTorch. Click on create. And this will start creating the entire environment for us. It may take a second depending upon the system here. All right, so as you can see, now we have the project created. Now let's do one thing. Let's start by creating a simple matrix, right? So here we can simply create a simple matrix, and now let's simply see the output as well. Now in here, let me increase the font size as well, so we don't end up straining our eyes. So for example, here we can simply import from Torch from future. So for example, here we can import from future, import print function, and now we can also import Torch library as well. Now in here, what we are trying to do is, suppose let's say we want to construct, let's suppose we want to construct we can say 5 by 3, or suppose 5 by 4 matrix. Suppose here we want to create a 5 by 4 matrix here, right? And for doing that, suppose here we can simply mention this as A is equal to Torch. We can use the Torch library, and again here we can empty it, and in here we can define the matrix here as 5 by 4. We can find the library here, and in here we can simply print X, or we can say print A that we have specified here, right? And again, same way, suppose if we want to randomly initialize a matrix here, suppose let's say we want to randomly initialize a matrix here, we can simply define the output altogether as well. So now same way, if we want to randomize, suppose if we want to construct a randomly initialized matrix, right? So for example, here we also want to create a, let's say, suppose randomly initialized, right? Initialized matrix, right? So again, we can simply use, suppose here we can specify this as suppose A. Again, here we can use the torch library, and again, since we are using this for randomized, we can again specify 5 by 4, and then now here we can simply specify the print A here, right? And suppose, let's say we want to construct a tensor. If you are looking to construct a tensor as well, suppose that here we are looking to construct a tensor that we had discussed, right? We had discussed the concept of tensor as well. Again, we can specify here, suppose again, we can use the torch library here as tensor, and then we can specify, right? Suppose here we're looking for 5 by 4, right? And then suppose not exactly 5.4 here, suppose here now when we're using tensor here, we can specify this as 5.5, and then we can specify 4 here as a part of value, and then we can print A again, right? So first of all, now remember, whenever we are using the torch library here, we do have to import torch library, without which we won't be able to print this up. We won't be able to print this up here. And suppose same way, suppose if we want to override any particular data type as well, if we want to override any existing data type, we can also do that, right? So for example, here we are looking to override a data here, right? For example, let me show you how to type that up here as well. Same way, if we are looking for override data type here, we can simply specify again. Suppose here we have one data type as torch, right? Yeah, we can again use the torch as the same torch library here. Now in here we can use the same random, and then here we can specify, suppose say if you're looking to change it. Now suppose say here we are looking to change the data type here, right? For example, like suppose if we are defining this for X here, and now we want to change the data type to something else, right? We can specify that. Suppose let's say we are looking to change it to the float value. We are looking to change it to float value here, right? We can specify that again, then we can simply start printing A as well. Depending upon our requirement, we can change accordingly. We can change accordingly here. Same way, if you want to change it to float, or if you want to change it to double, we can do accordingly. We can do that accordingly. And now if we have to talk about how exactly we can train a neural network, right? So basically, whenever we are creating a neural network, there are multiple processes that we have to take care of, right? So first of all, we can define the entire neural network here, right? And then we can iterate over a given data set. Then we have to process the input here. Then we can compute the loss incurred. Then we can propagate gradients back. And then at last, we can update the weights altogether, right? And again, for use for updating a weight here, we can simply define weight minus learning rate multiplied by the gradient that we have, right? When we simply propagate the gradients back as a part of our entire process for creating the neural network here, right? And basically now in terms of, first of all, we have torch sensor. So now in torch sensor, it's simply a multi-dimensional array with support for autocad operations, like we have for backward. Then we have in the NN module, we have the entire, now it is simply a neural network module for encapsulating parameters, right? And then we have parameter, again, it's simply a tensor which is registered as a parameter, right? And then we have AutoCAD function. It simply helps us in implementing forward and backward of definitions as a part of AutoCAD definition altogether, right? And if we have to compare how PyTorch stands as in comparison to TensorFlow, so PyTorch is again used for dynamic computational graphs, where the TensorFlow is used for static computational graph altogether, right? In PyTorch, we can make use of standard Python flow control, whereas TensorFlow can make use of, again, cannot use the Python flow control as compared to PyTorch, right? And here we have the full support for Python debuggers, and again, we don't have the support for Python debuggers in TensorFlow, right? And here we can inspect variables and gradients both, where variables and gradients can be checked, but again, the dynamic checking is not available in TensorFlow altogether. It is all manual, right? And basically, this is used for research, whereas this one is basically used for production, and that too for big scale data sets when we have, because again, TensorFlow setup and TensorFlow development is not easier as compared to PyTorch, right? That's why it is more widely used in context to the large data sets. Large and more complex situations are basically solved using TensorFlow. And then if we have to understand the basic use cases of PyTorch, so we have seen that generating a simple image classifier, right, which can predict image sets by constructing a neural network. So basically it is useful for image classifications, right? And just like Google uses the image to text applications, right? We have translations. And just like we have discussed the use case for Google Lens as well, and we see a signboard written in different language, right? Then as soon as we point Google Lens to that particular signboard, we would be able to see a real-time translation done for that signboard in the app itself, right? So again, this is basically a small use case for PyTorch. Now, although PyTorch is not directly used there, but again, a small use case that can be available for PyTorch here, right? And using this, we simply do what? We simply improvise the accuracy, because again, that's the main job here, to increase to make the entire model as accurate as possible, right? And if we are looking for data sets here, then standard Python packages can be used to load data into the NumPy array, and then it can be converted into Torch tensor that we have seen already, right? And for again, these are already different data set available. For images, we have Pillow and OpenCV. For audio, we have CPy, and then we have Librosa. And for text components, for text data, we have Spacey, and then we have Cython, right? So these are different libraries for which is used for processing these different data sets here. Where in image, the most popular is OpenCV. In audio, we have CPy, and in text, we have Spacey as well, right? So these are the most popular libraries for processing data in these different formats here for images, audio clips, and text components. Thank you so much for joining, guys, and have a great day ahead. Take care. Bye-bye.